Hello and welcome. This presentation is called Introduction to MicroPython, and my idea here is to give you guys a big picture overview of MicroPython and tell you a bit about why it's interesting and relevant. Now, I don't think that it is possible to talk about MicroPython without getting into the topic of microcontrollers, for example, because MicroPython is a brand new implementation of Python that's designed to run on microcontrollers. But then if you want to run it, what's the simplest way? It turns out to be the BBC Microbit. So these are the three things that I'm going to be talking about throughout this presentation. And I think the best place to start is actually to talk about microcontrollers. So what are microcontrollers? Well, a microcontroller is a computer on a microchip. It is programmable and it has pins, which are generally called GPIO pins. General purpose input-output. So they can be attached to sensors and output devices. They also have obviously like a processor as well as memory. So they're very much like a computer, except we're talking about multiple orders of magnitude slower, multiple orders of magnitude less memory. So thousands and millions of times lower specs than the PC or a tablet or the mobile that you're watching this video on. So given that they have such low specs, you'd probably be surprised to hear that there's more microcontrollers on Earth than computers. There's more microcontrollers than people. There are probably several microcontrollers in each computer. And I'll describe why next. So why microcontrollers? Look, if you want to interact with the real world, you need something other than a computer. See, a computer is a limited device in that, let's say a tablet, you've got the touch input, and that's maybe that has a microphone so you can speak to it. And the output is pixels on a screen and sound. Computer, same thing. Keyboard, mouse, pixels on a screen, sound. So if you want to interact with the real world, you want to interact with a car or open up a garage or interact with a plane or building, anything in the real world, you need to interface with sensors. So sensors that can sense the environment, sound, touch, maybe temperature, water. There is virtually an infinite amount of things that we could sense in this world. And you need output devices. A variety of maybe lights, lasers, motors, servos. So output devices, anything that's robotic that you've ever seen, from from all-out robots that are semi-autonomous to robot arms in factories. All of those are output devices that are connected essentially to microcontrollers. Probably on multiple levels, there's smaller microcontrollers that regulate circuits within them, perhaps making sure that like the battery doesn't overheat while others control the actual device. So yeah, why microcontrollers? Because they are what interfaces with the real world. If you want to program machines to interface with the real world, you need microcontrollers. And where are they used? Well, everywhere. All of your white goods in your house they have any decision-making capacity, they have a microcontroller. Like if you have a kettle that has a temperature setting, like I do, that has a microcontroller in there attached to a temperature sensor. Your air conditioner, washing machine, anything that's programmable to do a particular type of cycle, there's a microcontroller that saves those programs and you select those programs with buttons. There are many microcontrollers inside a modern car. Like a typical one would run a cruise control. They are built into various, smart devices. Back in the day, a phone used to be a microcontroller attached to some memory. Now your phone has multiple microcontrollers that control the sensors and as I mentioned earlier, are attached to battery circuits, making sure they work correctly. Maybe some other examples. Yeah, old toy robots, things on the road, traffic lights controlled by microcontrollers. So that's where they are. And where are they going to be in the future and how they're going to be used? Well, this is probably something you've heard of, Internet of Things. So this idea that we've had these small chips that control, anything from your dishwasher to vacuum cleaner to some toy that you buy, that's been around for a long time. However, Now with 5G, now with low power wireless communications, we are seriously entertaining the prospect of having all of these devices talk to each other or talk to some central location in the cloud and collectively process that data to make smarter and better decisions. This sounds a bit nebulous, but let's look at some practical applications. So here in Australia, this is a project going on right now. It's called the Fire Blanket. It's a partnership between CSIRO and an insurance company called NRMA. And the idea is that you attach microcontrollers with smoke sensors in a mesh network all around the areas that are at risk of bushfires. If one of these senses either smoke or heat, smoke is apparently the most reliable thing to sense, it can report to others, which can then talk to the internet and alarm the residents in the area. It can alarm the firefighters. They can plan a coordinated response. Another application, and this is being worked on right now, is if as I said, all the traffic lights are controlled by microcontrollers. Now imagine you're in an ambulance. See, in Australia, ambulances break all the traffic rules, and they get involved in a lot of accidents, and you can imagine that that's tragic because they're trying to save someone's life who's there. Well, guess what? If all of the traffic lights were in the same network, and they're all controlled by microcontrollers, they could all open up green lights for that ambulance to get to hospital as fast as possible. These are just two applications of microcontrollers within the Internet of Things that I could think of the top of my head. There are thousands. This is considered to be the biggest technological industry of the future. So now we've covered microcontrollers, their applications, their future. Now let's get back and talk a little bit about MicroPython and why MicroPython is awesome and interesting. So typically microcontrollers are used in compiled languages. They're written in something that's very similar to C, if they're not basic, but all of the ones in sort of the professional field are based on C. And this is fairly hard code to program. Python is a lot more intuitive. And so if you could bring Python into microcontrollers, that would be awesome. Now, Python is a slow programming language because it's interpreted and not compiled, but finally the specs of the microcontrollers are increasing. So Python on microcontrollers has become a viable concept. And in fact, a guy called Damien George sensed the trend. He happens to be also from Melbourne, where I live, and I happen to know his sister. Funny. Sidetrack. But he came up with this idea that, yeah, he was going to try to write a Python implementation for microcontrollers. He did that from scratch, and indeed, the software is awesome. So why Python and microcontrollers? Well, Python does data and mathematics really well and really easily. So that's one of the first things. If you think about microcontrollers and control systems, you think about doing maths that involves, integrals, roots, multiplication, squares. There's basically a certain level of calculus that's involved in really smooth controller devices. And Python can do that a lot easier with its math libraries than its C-based counterparts. You've got additional libraries that are specific to MicroPython, and it's easier to write libraries in Python than it is to C. And in fact, most devices that MicroPython works on have their own additional libraries. One of the best things about an interpreted language is that you could write one line of code at a time and test it out. There is a sort of REPL interface. This really makes debugging and makes your life easier. Not only that makes your life easier, you can actually program Microbit, which is a MicroPython compatible microcontroller, through the browser. So typically you would have to install drivers, you'd have to figure out how to interface your computer with that. You might have to install other IDEs on your computer. Whereas Microbit, for example, you could program through the browser. You could plug it in, have a program running in 2 minutes. That's not a user experience that people who use microcontrollers usually expect. In fact, it's a lot better. And finally, yeah, I already mentioned easier handling of data and interface with other systems. So if microcontroller does a particular job in a larger system, it would send out information in bits, bytes, maybe tables or JSON files. All of this data handling is easier with Python than it would be typically with C-based microcontrollers. So if you want to know what libraries are available, obviously, if you think running Python on a microchip, there's going to be a lot that's there in usual Python libraries that obviously can't fit on a microchip. So like SciPy, NumPy, Matplotlib, all of those big data science libraries, none of them are out there. But the standard functions and exceptions are in. The math and the complex math modules are in. There's a whole bunch of other specialized ones, many of which I've never used, that are in MicroPython as well. In terms of warnings, for those of you who are moving from Python to just programming a microcontroller, there's a talk that you should watch. Here is a link. It'll be linked in the description. Basically, you should be aware when trying to program in MicroPython that if you want to do a large program, maybe something object-oriented, or if you want to do an application that is speed-sensitive, so you're maybe trying to make decisions in microseconds, you have to adopt a certain style of programming and certain habits. For anything that I'm going to be teaching on this channel for the next 2 months, which is going to be the basics, this isn't even relevant for you, but if you were trying to do either very large applications or speed-sensitive ones, have a look at this talk and be aware that there is a particular style of programming that will make your MicroPython programs faster. I guess another comparison that's worth making is a lot of people that watch this channel are big fans of Arduino. I've made a lot of Arduino tutorials, so I figured that it's worth comparing MicroPython with Arduino. So MicroPython, in terms of speed versus Arduino, well, most microcontrollers that run MicroPython are a lot, faster than Arduino Uno. But the language itself, Arduino would be a lot faster because it's a compiled language. Arduino essentially runs machine code. All of the sort of general purpose, bigger, higher level stuff happens on your computer. So Arduino would be faster. Ease of learning the language. I mean, Arduino only has, a built-in 30, 40 functions, so it's quite easy. But MicroPython is honestly even easier. In terms of mathematical capability, I'm not that experienced doing complex math stuff with Arduino, but I found it a whole lot harder to do it in Arduino than MicroPython. So from what it appears, MicroPython, at least to me, is a lot better. Data manipulation, Python beats every other language in that, with the possible exception of R, but there's no R for microcontrollers. Now, file systems. So MicroPython, by default, either sort of creates a virtual file system on the machine it runs, or actually uses the memory of the board that it has. So you can store multiple files. You just run the main, and the main can call other files. Whereas with Arduino, that's board dependent and a lot more complicated, again, going back to the fact that it's a compiled language. And finally, in terms of advanced sensors, so you would have digital that are on-off, analog. Any microcontroller can interface with those. But I'm talking about, a camera or, 3-axis accelerometers. There's sensors that require specialized libraries. Now, there are libraries for every possible sensor that I've seen out there in Arduino. This is, in terms of interfacing with a random device, Arduino is still a lot better than any Python microcontroller. So I think that covers that. Okay, installing MicroPython. This is a topic for another video. If you have the Pi board or ESP32 or one of those boards, you're going to need to go through a process of downloading the repo from GitHub. You're going to need to download drivers, install Python libraries. It's actually complicated. Luckily, though, there is a very, very easy place to start, and that is called the BBC Microbit. So a little bit about this project. About, I don't know, 3-4 years ago, the English government, Microsoft, and a whole bunch of basically chip makers got together and made this board that runs both a Blockly style, like JavaScript style, I think it's called TypeScript, coding interface made by Microsoft, and MicroPython. Now this board has some awesome features. I'm going to discuss them in the next page, but the best part of it is it's designed for high schools, and it's a microcontroller that you plug into the USB. You don't need admin rights. You don't need to install a driver. You don't need to change any port settings. It's just like a USB. You drag a file in and it runs the program. So it's the easiest by far microcontroller to use that exists in the educational space or in the world. And the specs of it, well, they're quite impressive. So you've got a 16 megahertz 256K flash 32-bit microcontroller. So this would be already hundreds of times better than an Arduino Uno. Now, there are several modes of 2.4G wireless communication. Actually, I misspelled Bluetooth there. But it can either communicate with Bluetooth or several other protocols. It's really kind of high level when you use it. I'm not sure what protocol it uses, but it's really, really effective, and it doesn't spend a lot of energy. Like, I could have a microbit in my fridge, which is 2 rooms over there, locked in, and it could communicate with a microbit that I have here, and I could read the temperature from the microbit in my hand. So that's really impressive for low power Bluetooth. So next up, you've got built-in push buttons. There's actually 2 on the microbit. Then there is a 5x5 LED grid. There's a 3-axis accelerometer and the temperature sensor. The temperature sensor is inside the actual sort of microcontroller chip. There are 19 assignable GPIO pins. And as I said, there's a USB loading of the programs and an overall fantastically low level of power consumption. So I think that is the overview of MicroPython, Microbit, and microcontrollers. I figure I'm going to end this video with some simple examples of code running on the BBC Microbit so you guys get an idea of what it's like. Alright, so I am in Google and I just searched Microbit Python. And in less than 60 seconds, we're going to get a program on this microbit. We're going to start by connecting it to a USB micro cable. Click. So it has the previous program that was running on it. Your computer is going to treat it like a USB. This interface is going to come up with a default program, which is basically a Hello World program. You can then download your program to the microbit, which it treats like a USB. Click Save. The microbit will blink at the back, and you're going to see this Hello World message. About 45 seconds. That easy. Now let's maybe change that to some kind of a counter program. We can have a counter equals to 0, and we can iterate that counter. Counter plus equals to 1, and then we can say display that. Perhaps we'll leave that scrolling thing there, wait for 1 second, and show string counter. Now, in theory, this should work. So we download it, we save it, it will blink, and hopefully we're going to see the numbers counting in a second. 1, 2, 3, so on. So there you go. It is that easy to put Python programs onto the microbit. Let's have a look at a little bit more of an advanced example with a different IDE. So next I'm going to show you Moo, which is a Python IDE that downloads programs to the microbit with one single press. And this here is an example program that displays the temperature. Currently 24 degrees. That takes 3 lines of code. Now, one little problem with Moo is that it interferes with my webcam, so I'm going to have to pause it and show you the next program. This right here also takes a couple lines. It basically takes accelerometer readings of only one of the axes, and it says if you shake it, it'll produce a skull. Then we'll go back to smiley face, shake it, produce a skull. And the next program I'll show you is a more advanced implementation of the accelerometer. So right here we have a more advanced version of the accelerometer. The more you shake it, the more life disappears, and eventually, boom, you get a skull. And this measures all three axes, and it has this sort of pixel by pixel display. Finally, this is a game where you are trying to be the pixel at the bottom, dodging the pixel at the top, and if it hits you, you lose. This uses the buttons in the display, and I think that about covers it for some basic examples. So guys, I hope you enjoyed that, and thanks for watching all the way until the end. Stay tuned and do subscribe to this channel. We've got 20 plus MicroPython tutorials coming over the next 3 months, and a lot of live events and webinars that are going to be announced. As for other tutorials, within a day or two, I'll be posting the reaction time right there and the brick dodging game right there. That's all for now. Enjoy yourselves. See you later.